Hello children, chapter 9 Mechanical Properties of Solids. See, the motion of a body depends on how mass is distributed within the body, right? As we know that. And the properties of bulk matter. Through that, what we are going to learn. See, as we said the statement, the motion of the body depends on how the mass is distributed within the body. And we restricted ourselves to simpler situations of rigid bodies. So a rigid body generally means a hot solid body, right? Having a definite shape and size. But in reality, bodies can be stretched, compressed and bent. Even the appreciably rigid steel bar can be also deformed when you are giving a sufficient large external force is applied on it. This means what you can understand? Yes, the solid bodies are not perfectly rigid. A solid has definite shape and size. In order to change, that means we can call it as in terms of scientific notation, deform the shape or size of a body. A force is required, an external force is required to deform the size or shape of a solid. If you stretch a helical spring by gently pulling its end, the length of the spring increases, right? When you leave that, it regains its original size and the shape. So this property, we can call it as elasticity. As we take as the base for the properties of solids, we have different properties, that is elasticity, plasticity, like a different. One by one we will see. Now elasticity. See, the property of the body to regain its original configuration, that is the length, volume or shape, when the deforming forces are removed, that we can call it as elasticity. As we said, if you stretch a helical spring by gentle pulling it, the length of the spring is increases, right? When you leaves it, once it regain its original shape and the size, then only we are calling it as a elastic nature, right? And what is perfectly elastic body? A body which regains its original configuration immediately and completely after the removal of deforming force. That we can call it as perfectly elastic body, like quartz, phosphorus, bronze. These are all some examples we can say. And what is plasticity? See, some of the substances we are calling plastic, and their property we can call it as a plasticity, right? The inability of the body to return to its original size and shape even on removal of the deforming force. That we can call it as plasticity, right? So what is the elastic behavior? So before we are going to know about some terms, how to change given the shape for reforming the shape, you must know about the elastic behavior in terms of interatomic forces. See the graph. The atoms in a solid are held together by interatomic forces, right? Through the graph, you may understand that the variation of the interatomic force F with the position R, which is equal to R naught, whenever the force with the position of R which is equal to R naught, that is the stable equilibrium. If suppose the force is, that means R is less than the region of R naught, we can say F is repulsive. And for R is greater than R naught, the force F is attractive. Now, one by one, the different stress and the strain. If suppose you have given a stress on a body, it will get strain, right? Suppose when tensile or a compressive force is applied on a body, its atom are pulled apart or pushed closer together to the distance r. So what is tensile or a compressive force we are applying? So these are all the different types of forces which is given to that particular body from the external force. So we can see that. Stress. What is stress? So stress is defined as the ratio of the internal force F which is produced when the substance is deformed to the area A. So we can say the stress, which is nothing but the applied force per area. That means the internal restoring force set up per unit area of cross section. Right. So stress which is equal to F by A, that is nothing but the applied force by area. The SI unit of stress is, yes, Newton per meter square, and the CGS unit is Dyne per centimeter square. The dimensional formula of the stress is M L power minus 1 T power minus 2. Have you all got what is stress? Generally, we can say that stress which is nothing but the applied force per unit area. Got it? Now, what are the type of stress? So, this is majorly we can say two types. One is normal stress, another one is tangential stress. See, normal stress, which is nothing but the restoring force per unit area is perpendicular to the surface of the body. The normal stress, we can say that only the tensile stress and compression stress. What is tensile? See, the tensile stress, which is nothing but restoring force set up per unit area of the body when the length of the body increases, right, in the direction of the deforming force. The length, the change in the length, that we can call it as a longitudinal stress. Okay. The compressional stress. Compressional stress, which is nothing but this gives decrease in length when we are giving a stress on a body, that is the restoring force set up per unit area, the body when the length get decreases under a deforming force. Right. Tangential stress, which is nothing but when the elastic restoring force or deforming force acts parallel to the surface. So that stress we can call it as a tangential stress, or we can say that shearing stress. One by one we can see in detail. Normal stress of two types, that tensile and compressive, tangential, all that only definition I explained. We'll see one by one in upcoming slides. Now what we said, we have given some stress on body, it will get some strain. Is it right? So now what is strain? So strain, it is defined as the ratio of the change in size or shape to the original size or shape. It has no dimensions, just it's a number. Right. So we can say strain, which is nothing but change in dimension by change in the original dimension. That means the ratio between any other dimension which is produced in the body to the original dimension. Right. And these are all the three types: longitudinal strain, volumetric strain, shearing strain. Understand? What is longitudinal strain? Longitudinal strain, which is nothing but the ratio of change in length to the original length. That means longitudinal strain, which is equal to change in length, right, dull L by original L, original length. See, the diagram can show that the length is getting varied. The ratio of change in length to the original length, we can say longitudinal strain. Volumetric strain. This is nothing but the ratio of change in volume to the original volume. That is change in volume dull V divided by original volume V. So this is volumetric strain, change in the volume. Right. What is shear? shear strain. See the angle tilt caused in the body due to tangential stress expressed in the shear strain. So we can say that as the angle theta through which a face originally perpendicular to the fixed face. Right. So the shear strain theta, which is equal to dull L by L, original. Right. That is nothing but what? The relative displacement between two parallel planes, dull L, whole divided by the distance between the parallel planes. So because it is changing in the angle, right? And you must know about what is elastic limit. The maximum stress within which the body regains its original size and shape after the removal of deforming force, we can call it as the elastic limit. As we said while we are telling the first example, that is we are stretching a spring. Is it right? Till if you have given the elastic limit, then only it will regain its original position, original limit. Now, you may see that through the flow chart, what are all we have seen? Stress and the strain. Types of stress, what we said? Normal stress, tangential stress. So normal stress, which means what? It has two types. Tensile stress, that means increasing in length. Compression stress decreases in dimension or length. Tangential stress means what? When deforming force acts tangential to the surface of the body. Right. The tangential force applied per unit area, which is equal to the tangential stress. Strain, the ratio of change in dimension to the original dimension, which we can call it as strain. It has no unit because change in dimension by the original dimension. What are the types of strain? Longitudinal strain, volumetric strain, and shearing strain. So longitudinal change in length, volumetric change in volume by original volume, shearing strain, that is theta, not phi, theta, that is angle change. Have you all got it, children? Thank you, students.